We looked at using the converse of the Pythagorean theorem to identify if it's a right triangle or not. We can take that one step further. Because if in fact a squared plus b squared equals c squared, we know it's a right triangle. If in fact it's not equal to it, where it's less than or greater than, then we know it's not a right triangle, but at this point we don't know whether or not it is acute or obtuse, which are the other types of triangles we can have. I want you to visualize that if in fact it makes a right triangle, then this side length squared and this side length squared contribute to the left side of the equation, whereas the hypotenuse contributes to the right side of the equation. And as in this example, we see that the left side of the equation is too large. In other words, the hypotenuse is too small. Therefore, instead of it fitting like it should here, if the hypotenuse is too small, this side length here has been brought in to address a shorter hypotenuse. Therefore, instead of it being a right angle, this would make it acute. So if the hypotenuse is too small, pinching the triangle in, then it makes an acute triangle. So if the hypotenuse is big, no, the hypotenuse is too small, then it makes an acute triangle. Similarly, if in fact we had seen that the hypotenuse was too large to fit into what we know is our leg squared, then that would force it to be obtuse. So these are our formulas. If a squared plus b squared equals c squared, it's a right triangle. If a squared plus b squared is less than c squared, such that the hypotenuse is too big, alligator's eating the big one, then it's an obtuse triangle. If, on the other hand, the hypotenuse is too small, the alligator's choosing to eat the other side here, if that's too small, then it's an acute triangle. So we could fill these back in as we did. Now we're going to practice here, 7, 8, and 9. So 9 is the biggest one, so I want to set it up as though it were Pythagorean theorem. See if it works. 49 plus 64 is 81. 113 and 81. In this case, my inequality points this way, suggesting that 81, which represents my single side, my hypotenuse, is too small. That's this scenario with the red. It's acute. This is an acute triangle. Is the triangle acute, right, or obtuse? It's acute. Second one, again, remember that the 10 is out of position, so we have to write this as 6 squared plus 8 squared is equal to 10 squared. 36 plus 64 is equal to 100. 100, 100. That is equal. Therefore, we call it a right triangle. Third scenario, 3 squared plus 5 squared equals maybe 7 squared. 7 is my biggest one. It goes off to the right. 9 plus 25 is maybe equal to 49. 34 and 49. My inequality goes this way, showing that my hypotenuse is too big. If my hypotenuse has been opened up too wide, that makes the triangle obtuse. Hope this helps in classifying triangles based on side lengths.